Have you ever pondered what would happen if our planet suddenly stopped spinning? It's a scenario that challenges our understanding of Earth's dynamics and the delicate balance that sustains life. In this video, we delve into the profound and catastrophic consequences of such an event, exploring the immediate and long-term effects on our world. Earth rotates on its axis at approximately 1,670 km per hour, 1,040 miles per hour, at the equator. This rotation is responsible for the cycle of day and night, the Coriolis effect influencing weather patterns, and the equatorial bulge due to centrifugal force. It's a fundamental aspect of our planet's behavior, affecting everything from climate to the behavior of the oceans. If Earth were to stop spinning abruptly, the atmosphere would continue moving at its original speed due to inertia. This would result in unprecedented windstorms, with air masses moving at over 1,000 miles per hour, devastating everything in their path. Structures would be flattened, and the landscape would be reshaped by these colossal forces. The inertia of the oceans would cause water to surge towards the poles, generating massive tsunamis that would inundate coastal regions. The redistribution of water would not only cause immediate flooding but also lead to long-term changes in sea levels and ocean currents, disrupting marine ecosystems and weather patterns. The sudden stop would place extraordinary stress on Earth's crust, likely triggering a surge in seismic activity. Earthquakes would become more frequent and intense, and dormant volcanoes could erupt due to the redistribution of tectonic pressures. The geological upheaval would further compound the disaster, making survival even more challenging. Earth's magnetic field, generated by the motion of molten iron in the outer core, shields us from solar and cosmic radiation. Stopping the rotation would likely halt this geodynamo effect, causing the magnetic field to weaken or vanish. Without this protection, the planet would be bombarded by radiation, increasing the risk of cancer and damaging electronic infrastructure. A non-rotating Earth would result in one side facing the Sun continuously, while the other remains in darkness. The sunlit side would experience extreme heat, possibly rendering it uninhabitable, while the dark side would plunge into freezing temperatures. These conditions would disrupt ecosystems, agriculture, and water cycles, leading to mass extinctions and food shortages. In this new world, humans would be forced to migrate toward the twilight zone, the narrow area between the scorched day side and the frozen night side. Here, temperatures might be tolerable, but survival would still require monumental technological intervention. Communities would rely on underground cities, solar collectors, and geothermal energy to create habitable microclimates. Agriculture would be moved indoors, and food production would depend on artificial lighting systems. Global cooperation would be essential, but political fragmentation and resource scarcity could lead to conflict and collapse. Only the most prepared, well-equipped, and adaptable societies would stand a chance. The human brain is wired to follow circadian rhythms, 24-hour cycles governed by sunlight. With no sunrise or sunset, those rhythms would disintegrate, leading to chronic insomnia, depression, and psychological distress. Time itself would begin to feel meaningless. Societies would be forced to rely on artificial clocks and timekeeping to retain any semblance of order. Religious rituals, work hours, social activities, all would have to be redefined. A life without natural time markers would change not just our biology, but also the very way we think and feel. Currently, Earth is slightly flattened at the poles due to its rotation. Without that spin, gravity would pull the planet into a more perfect sphere over millennia. Tectonic activity might settle as the crust readjusts, but with altered heat flows and pressure zones, new land masses and ocean basins could emerge. Our orbital stability might also change. The Earth's spin interacts with gravitational forces from the Moon and Sun. A stopped rotation could destabilize those relationships, potentially altering the length of a year or the tilt of Earth's axis, again reshaping climate and seasons. The truth is, Earth is slowing down, just very, very slowly. Tidal friction caused by the moon pulls on our oceans and ever so slightly slows the planet's spin, by about 1.8 milliseconds per century. At this rate, it would take billions of years for Earth to stop spinning naturally, far beyond the expected lifespan of our Sun. So, while the idea is fascinating and terrifying, it's more likely to happen in science fiction than reality. Still, understanding what could happen helps us appreciate the fragile equilibrium we live in. This thought experiment reveals a powerful truth: life on Earth is possible because of countless delicate balances, gravity, magnetism, orbital mechanics, and yes, rotation. Take away just one of those, and everything falls apart. The spinning of Earth isn't just a cosmic accident. It's a cosmic miracle. So the next time you feel the breeze on your face or see the sun rise, remember, it's all part of a perfect rhythm that has lasted for billions of years. And continues, moment by moment, to keep us alive.